To say that technology is rapidly changing how we live our lives is an understatement, to say the least. Think about a little more than 100 years ago, a horse pulling a carriage was still state-of-the-art in travel for many people around the world. But in just a few short decades, motorized vehicles became the norm, edging out the different modes of travel that people had been used to over their lives. In the intervening decades, the pace of technology changing the status quo has not slowed down. In fact, it has increased exponentially in virtually every field imaginable, including aviation. Not long ago, it could take more than 25 hours to fly across the U.S. by passenger plane. Today, it takes less than 5. And air travel is safer and more reliable than ever, thanks to the pioneering work performed by NASA and many others in the aviation community. But there is a new change coming, just over the horizon, that will revolutionize and reinvent our understanding of aviation in our world once again. That change is in urban air mobility, or UAM. This concept could see on-demand air taxis flying around large metropolitan cities in coming years, which will change city landscapes and the thought of how we travel forever. By the middle of this century, 70% of the world's population will live in urban areas, and mobility within these cities will require different solutions than we have today, which is why urban air mobility seems so promising. UAM technology is already here and being perfected by industry partners and government agencies like NASA and the FAA. But it is poised to break out and be a mainstay in our lives, potentially as early as the mid-2020s. With this quick turnaround time, NASA and its partners are already looking into how to safely transition urban air mobility into our daily lives. Just as the jet engine revolutionized aviation in the last century, UAM promises another revolution in this century. This new capability and this new way of travel will be a complete paradigm shift and could entirely transform the urban landscape and change our travel lifestyle. Coming up on this episode of NASA X, we will look at the current state of the art for UAM to see where this technology stands today. We will also see how NASA plans to contribute to the development and integration of these vehicles, while also looking out to the future to see how these new types of vehicles will transform our world and how we get around in it. NASA's vision is to revolutionize mobility around metropolitan areas by enabling safe, efficient, convenient, affordable, and accessible air transportation systems for passengers and cargo. For the layperson, that basically means that NASA is working on the concept for flying cars and delivery vehicles right now, in the hope to make them an everyday part of our lives in the future. Although the idea for new urban air mobility is truly exciting and could be the Big Bang event for future travel, the idea is not a new one. As early as the 1930s, the flying car was being considered as a viable form of travel here in the U.S. The head of the U.S. Bureau of Air Commerce, Gene Vidal, a former Army pilot and father of author Gore Vidal, announced the Bureau's plan to make owning a personal aircraft as commonplace as owning a Model T Ford. The Bureau invited aircraft manufacturers to design a simple, safe vehicle that would sell for a target price of only $700. Obviously, that plan didn't work, but the idea of this type of travel has never been far from our thoughts. Popular science fiction often showed this type of flight in our cities, and many aircraft designers came up with interesting vehicle ideas. But until now, these older technologies could not meet the stringent safety and economic requirements here in the U.S. Only in the past few years has public acceptance and new enabling technologies, such as an ability to manage massive data sets, electric power and propulsion systems for quiet sustainability, and affordable miniaturization of vehicles, been within our grasp.
So there's many research challenges which NASA is looking to help with, some of which we've already begun research in, some we plan to start research in the near future, and partner with industry and with the FAA on that to be able to make a system ultimately all come together and to work out in a way that's safe, efficient, and that can revolutionize the way that we travel.
But even though we are at the beginning stages of this new standard for travel, there are many hurdles that we must still overcome. Just look at our current air system as an example of the complexity of air travel today. You can see the tremendous amount of time, money, and effort that it has taken to get us to where we are today. Our current air infrastructure has been years in the making and fuels a huge part of our economy. It's hard to calculate how much this brings to our country when you consider all of the airports, airplanes, infrastructure, jobs, and numerous ancillary offshoots. But it is fair to say that aviation is a multi-billion-dollar per year industry and a huge part of our daily lives. Although this system works extremely well today and we are all used to the way we currently travel, the shift to novel vehicles, specifically those designed to fly in the urban environment, will be a very challenging one.
So for most of us, airplanes, we use large commercial transports. Typically something people don't use unless they're traveling long distances. If you actually look at travel statistics, most people don't consider flying commercially until they're going beyond 500 miles. Obviously that's a small percentage of the trips we take. Cars are really good out to about 50 miles or so, even less than that if you're talking about going through an urban area where the speed of traffic might take you down. In some places like LA, for example, the average speed gets down to 10 miles an hour. So we're really looking at urban air mobility as providing medium range transportation as short as 10 miles in very congested areas, out to, if we're talking urban air mobility, 60 miles might be a long distance trip, but other applications of small electric aircraft could go out to that 500 mile range. And these would be something that you could schedule, on demand, similar to an Uber car or same day kind of thing. So making how we use air transportation much closer to how we use cars today.
But this new market won't emerge overnight. UAM will start with a mix of onboard and remotely piloted vehicles and progress toward autonomous operations.
So, the 15-mile trip in the next 10 years, probably what you would do is schedule that using an app on your smartphone. You would meet your ride at some sort of a local vertiport. That might be a mile or two away, so there's a short ground segment. The aircraft itself would be relatively small, might carry 4 passengers, or maybe even, once we get to fully autonomous operations, it could be just you on board. So it would meet you at that vertiport. The air segment of the trip would be pretty short, 5 minutes or so. And then at the other end, you'd also land at another vertiport, catch your ground transportation to your final actual destination. It's all about, short, medium distant trips, traveling by yourself or your immediate group of travelers, rather than, it's really personal transportation rather than mass transportation like we think of aircraft today. Definitely has to be affordable, and if you look at the convergence of technologies that's occurring, electrification, autonomy, it's making it so realistically the cost per mile of the trip can be much more car-like.
Car-like adoption is intriguing, but making this all work is one of the most complex tasks ever taken on by an engineering team. As an example, at peak times in the U.S., there are roughly about 10,000 flights in the air flying all over the country. But with the advent of UAM, we could see 10,000 flights in the air over just one metropolitan area. The complexity of this integration is daunting, so NASA has broken down the challenges into 5 pillars where technical progress needs to be made. The first area is the basic design of the aircraft. Although NASA won't be building an aircraft that you fly on, they will provide technical leadership in areas that require the UAM community to work together.
Most of these vehicles will be all electric, meaning that noise and greenhouse gas pollution will be greatly minimized. The vehicles will carry 2 to 4 people, allowing for personal transportation by air and also encouraging ride-sharing. The air vehicles will have a speed of around 100 miles per hour and will operate at altitudes between 2,000 and 5,000 feet. These vehicles will be very efficient and safe because they will use far more autonomous systems.
As Dr. Shin mentioned, many of these new aircraft designs will have electric propulsion rather than use fossil fuel to run the engines. With these new technologies, NASA will have to work closely with the industry to certify that these designs are viable and safe for passengers. The second challenge is in the area of piloting. Aircraft today all have expert pilots on board. With UAM, eventually, many of the aircraft will be self-flying, or there will be a pilot on the ground flying the aircraft remotely. They will have skilled and trained pilots, but with more automation, the duties might be different than the duties of pilots today. The hope is that eventually we will move away from piloted aircraft and have fully automated aircraft over our cities to carry passengers and goods. And as that happens, NASA will be heavily involved in making sure that all systems work seamlessly. The third challenge area will be in designing an overall airspace architecture that accommodates all of these new aircraft while also integrating in the traditional aircraft that we use today. Today's aircraft fly in the national airspace. The U.S. air traffic control system is the busiest, safest, and most complex in the world, carrying over 1.7 million passengers daily. This air traffic control system consists of a dedicated workforce in control towers and centers, and a vast array of computers, radars, communications, and other equipment guiding aircraft safely to their destinations. NASA is working to integrate the NAS system with the new UAM system, which will be extremely challenging. The fourth challenge will be the real-time operation of that airspace to manage this increased level of traffic. That means using automation and technology in addition to trained air traffic controllers to manage these systems. The final challenge is in the area of community integration. That means integrating into our cities safely and with the smallest amount of noise, both auditory and visual noise. If we are increasing air traffic over metropolitan areas by thousands of flights an hour, much work will need to go into the safety of passengers and people within the cities, as well as noise abatement.
Noise will be a very big factor with these aircraft because we're talking about flying them, maybe not from your driveway, but somewhere not too far from your house, much closer than what we're used to with typical aviation. And just understanding noise sources on aircraft and ways that we can reduce those. There's a lot of research that NASA is currently doing and will probably continue to do to help feed the industry there and help push new ideas forward to help aircraft get more quiet and help them get more efficient, hopefully at the same time.
So how will this all work? Just as skyscrapers allowed cities to use limited land more efficiently, urban air transportation will use three-dimensional airspace to alleviate transportation congestion on the ground. Many believe that a network of small electric aircraft that take off and land vertically, called VTOL aircraft for vertical takeoff and landing, and/or aircraft that take off and land over very short distances, called STOL aircraft, will enable rapid, reliable transportation between suburbs and cities, and ultimately within cities. Even though initial costs will be a factor when starting this paradigm shift, the UAM transportation idea already has a major advantage over previous transportation revolutions like roads, rail, bridges, and tunnels. There are already many existing structures and unused land that can be repurposed for UAM aircraft, like tops of parking garages, existing helipads, and even unused land surrounding highway interchanges. Another benefit is that these novel aircraft do not need to follow fixed routes. Trains, buses, and cars all funnel people from A to B along a limited number of dedicated routes, which can cause serious delays if there is even one single interruption. UAM aircraft could travel toward their destination independently of any specific path, eliminating some of the major congestion issues. As we have mentioned, this is a total shift from our current state of the art. Everyone will have to work together to make this change as seamless as possible. To help make that happen, NASA has come up with what is being called the Grand Challenge to help get everyone on the same page.
NASA's planning to host what we're calling currently a Grand Challenge, which would be a place for different companies to come, bring aircraft and bring different airspace management solutions to test out what the future might look like. So one big thing that's recognized is, as we move into the future, we're probably not going to be able to have air traffic controllers sitting there talking to a human on board the aircraft to make this work at the density levels, the number of aircraft that we're talking about putting in the sky. So how do we get to the point where we have technologies that we trust that can safely make these aircraft interoperate with one another and stay away from things they're supposed to stay away from, go to the places where they're going to go, and make sure that they're all organized and managed in a safe way.
Many within the industry recognize the challenges ahead and are glad for NASA's involvement.
We've too often forgotten NASA. NASA, the first A is aeronautics, and NASA really serves a really critically important part. We really can't jump into making rules or regulating or all of that until we assess risk, until we have a good understanding of risk, we have a good understanding of the technology. So I think NASA is going to help us to really, in some ways, go into rulemaking, go into societal acceptance much better prepared. We're going to understand the risk, we're going to be able to quantify it, but these are the types of problems that NASA does well. We need NASA to help us to figure out these, what we always call the NASA hard problems. How do we do this? How do we do it efficiently? How do we do it safely? How do we do it more economically? So I'm excited. I think that the UAM community, the industry, if we could call it that now, is really doing this right by looking at NASA first. Before we jump into rulemaking, before we do all of the other things that unfortunately we've made the mistake in the past in aviation, I think we're doing it right. So I'm excited. I think this is the perfect role for NASA, and I'm excited that this could also possibly reinvigorate the aeronautics and the sort of terrestrial aviation side of NASA. So I'm excited about that part.
I think NASA has a few key roles to play. I think to the extent that they can dedicate their knowledge and experience in realizing visionary activities, I think this is an industry that really needs visionary governmental leadership. It needs it within communities, it needs it by the government, it needs someone to rally everyone around. I think NASA is a great organizing entity. They demonstrate that vision. People love NASA, so they love to get engaged. They have great community presence. And on the other side, they have an incredible breadth of knowledge around the technologies and enabling technologies that can make this happen. They really are one of our most valuable R&D assets that the federal government has. And in that sense, it's great to see them taking a leadership role in forums like this.
I think now we're on the cusp of it. I think we've got the great designs, and I think it's different than it has been in the past, since we have been talking about flying cars for decades. A lot of the technologies are now ready. Data processing, the materials, the manufacturing, the design tools, and the electronics and automation have definitely come a long way, that it is now the time to really push forward and make urban air mobility a reality. I think it'll be part of a bigger integrated system. So I think you'll have the cars, and you'll have enough cars to meet the demand. If the demand's large, you'll have a large number of cars. And cars are a definite personal statement. So I think you've got part of that, so people will want cars as a reflection and for ease and convenience. But it'll be part of a bigger transportation system, so you can take autonomous cars for trips that make sense for those. You'll have the subways and the buses and larger transport aircraft that go cross country. You have people that in the Midwest, where it is less densely populated, you've got much greater distances that you want to drive. If you're living in a smaller town that is a significant distance away from a major metropolitan area, and you want to go in for a show, to do some shopping or whatever, it's much more convenient for you to take an air vehicle from where you are to the city and back, vice driving a car and dealing with parking and all those other things. So you'll have a much more collection of choices and the ability to pick which is right for what you want to do. Flying helicopters for 20 years, I do have a little bit different perspective than a lot of my colleagues. And being able to see the landscape from the air and knowing what some of the challenges are has helped, contribute to the conversation of what we think urban air mobility will look like. It'll be interesting because I think the weather we'll see in the future will be much more refined, and you will have reporting on microclimates, so you won't just get the weather for your entire metropolitan area. You can probably get the weather for your local 3 blocks and the next 3 blocks, and have much better predictive systems to be able to plan your trip and to choose which mode of transportation is best for you.
So we're here now at the dawn of a new age of travel, ready to take the next steps. It may seem like science fiction right now, but perhaps in only a few years, this type of travel will be as commonplace as getting in your car is to you today. With the help of many thousands of engineers and planners at NASA and abroad, this science fiction may soon be science fact.